Hi everybody, welcome to HL Chemistry Flipped Classroom. Today we're going to be talking about writing chemical equations from word equations. And we'll look at some examples and hopefully we'll get this clarified for you. Okay, so a couple of just background stuff. Sometimes it's necessary for various reasons, either for clarity or for any number of reasons. You might want to put state symbols and let the person looking at a chemical reaction know what state the reaction or product is in. And it's pretty straightforward. G for gas, L for liquid, S for solid. If it's something dissolved in water, like a solution, like salt water, you use AQ for aqueous. And as a matter of fact, a very, very high percent of the time that we do chemical reactions, especially in this class, almost all the time, at least one of the reactants, if not both, will be aqueous. Something I just want to point out to you, take care in not mixing up the L and the AQ in the case of, for instance, NaCl. If I had NaCl liquid with an L behind it, what that would mean is pure salt, so 100% table salt that I have gotten very, very hot and melted because it's ionic, it has a high melting point. So super, super hot, molten like as in molten lava, sodium chloride. NaCl with an AQ behind it is very, very different. That's salt water. So you take some water, you add some salt to it. Notice both things are in the liquid state, but they imply very, very different things, so don't confuse the two. Okay, so like I said, what we're going to look at is we're going to look at word equations, so chemical equations described rather than written as equations, and we're going to transform them to chemical reactions, chemical equations. And you'll see what I'm talking about. We'll do a couple of examples. But what's really important is there's a couple of steps, and it's critical that you do them in this order. Okay? Your very first task is to write all of the substances involved in the reaction correctly. They must have their correct formula, and you have to do this first. I can't tell you how many times people will make mistakes in this area, but for ionic substances, this is going to involve, like we've talked about, adding subscripts to balance the charge. You should add state symbols if you can. In some cases, it might be absolutely necessary. Don't forget Mr. Brinkelhoff. We talked about this before, the diatomic elements. Bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, fluorine. And I said before, if you forget Mr. Brinkelhoff, you're going to get all sorts of things wrong and have all sorts of mistakes. And this is one case where that's true. Only after you have written every single substance correctly, then at that point you consider the reaction as a whole and add coefficients, the numbers in front, to balance for a number of atoms. So get one taken care of first, and then do two. Another thing, just kind of a side note, I'm mentioning it because it's going to come up probably from time to time, catalysts. Catalysts, we're going to talk about catalysts a lot at different points throughout this 2-year course, but they are things that speed up a chemical reaction, and they're always unchanged by it. So they're not really a reactant or a product. They just help a chemical reaction along and cause it to go faster. So, for instance, this is hydrogen peroxide, like the stuff that you put on cuts. That will break down into water and oxygen gas. It will break down a heck of a lot faster, though, if you use a catalyst, like manganese 4 oxide here. So, we're going to see lots of examples of catalysts. We'll probably see this exact reaction, if we haven't looked at it already, before the year's out. Okay, so let's look at some examples of what I'm talking about. So here's an equation written out in words, and we're going to transform it to an equation. Barium chloride plus sodium nitrate yield sodium chloride and barium nitrate. Okay, so step one is to write each substance correctly, thinking about charge balancing and everything else. So again, stuff builds in chemistry. We have to be able to do the stuff from last unit in this unit. So I'm going to try to struggle through writing it using this. So that's barium. So we know barium has a +2 charge. By the way, you're not going to be able to do this without your periodic table. We know barium has a +2 charge by consulting the periodic table. Chloride has a -1 charge. So the correct formula for barium chloride is BaCl2. And then sodium nitrate. All right, we got to remember our polyatomic ions. Got to think back to previous units. Sodium's got a +1 charge. Nitrate. Nitrate is NO3 with a -1 charge. So sodium nitrate is that. Yield. Maybe you should say yields there for proper English. So that's a clue that I'm going to put my yield arrow in there. Okay, sodium chloride. Now, again, our first step is to write every single substance in the reaction correctly. All you're worrying about right now is writing sodium chloride and writing the correct formula for sodium chloride. So what you do not want to do, and what a lot of people will do, is they'll write it like this, because they'll see that 2 over there and they figure they should just carry it over. Well, that is not correct. The formula for sodium chloride all of a sudden doesn't magically become NaCl2 in this instance. That does not happen. Sodium chloride only has one formula. It only has one possible formula. It's that, NaCl. Sodium's +1, chlorine's -1. We'll worry about this too later. This is the formula for sodium chloride. You know this is the formula for sodium chloride. It doesn't suddenly magically change to NaCl2. So first step is to write each substance correctly. And then barium nitrate. Again, what some people will do is they won't think about it, or they won't be thinking about charge balancing, and they'll just write a barium and a nitrate. Maybe they don't even know what nitrate is. Hopefully you still have your polyatomic ions memorized. But again, this is not the correct formula for barium nitrate. Barium nitrate, since barium has a +2 charge and nitrate has a -1 charge, barium nitrate is that. Okay, so we've accomplished step 1. We've written every substance. There's 4 substances here. We wrote them all correctly. You have to do that first. And then second, now we're going to balance for numbers of atoms. So we've got a polyatomic ion here. We're going to balance it as a whole. There's 2 nitrates on that side. So put a 2 there to balance the nitrates. Now there's 2 sodiums. Put a 2 there in front to balance the sodiums. That balances the chlorines. 2 chlorines, 2 chlorines. And then we're good to go. So now that one's all finished. If any part of that didn't make sense to you, stop, go back, take a look at it again, ask me a question next class, text your friend, talk to them on Facebook, if that's what the kids still do these days. But we're going to do a couple more examples, but do your best to get this figured out. Obviously, asking me questions and talking about it in class is a great idea too. Okay, so here's another one. Sodium metal and oxygen gas are combined to produce sodium oxide. So you can see this one's a little more written out as pretty much a complete sentence. Maybe it had a period at the end there. So our first task is to write each substance correctly. So sodium metal, alright, well that's just the element sodium, Na, and oxygen gas, okay, that's just the element oxygen, are combined to produce. Now wait a minute. Unless you're screaming at the screen right now, hopefully you're that passionate that you're screaming at the screen right now to tell me that I've made a mistake. Because I have. This is oxygen gas. Oxygen gas is part of Mr. Brinkelhoff, the element oxygen. Again, when we're talking about oxygen gas or the pure element oxygen, it always exists as O2, 2 oxygen atoms bound together. So the correct way to write oxygen gas is just like that, O2. Got to write each substance correctly first. So they're going to react to produce sodium oxide. Now, oxygen in a compound can have any coefficient, or rather subscript. It's only in pure elemental oxygen that it has the subscript 2 always. So again, we want to write sodium oxide correctly. We're not even going to worry about what's going on over here on the left. We're just going to think about charge. We're definitely not going to carry over this 2 and put a 2 there. We're just going to think about the fact that sodium has a +2 charge and oxygen has sodium has a +1 charge, oxygen has a -2 charge, so it should be Na2O. So that's the correct formula for sodium oxide. Now we're going to balance, in step 2, we're going to balance it as a whole by coefficients. So 2 oxygens here, put a 2 there, that makes 4 sodiums. So there you go. Okay, so I'm going to show you one more example. I'd like you to give this one a try. Potassium reacts with fluorine gas to produce potassium fluoride. So think about what we've been doing. Pause the video for a second. Your first step is to write each substance correctly, and then once you do that, balance with coefficients, balance for numbers of atoms. So pause the video, give that a try, and we'll come back and take a look at it. Okay. So potassium. Well, that's just the element potassium. That's K. Fluorine gas. Did you remember Mr. Brinkelhoff? The F in Brinkelhoff stands for fluorine. Fluorine is a diatomic element. When we're talking about the element fluorine, it will exist diatomically. Now, as part of a compound, it can have any subscript. Like in the case of potassium fluoride. Potassium forms +1 charge, fluorine forms -1 charge, so potassium fluoride should look just like that, KF. Step 1 is finished. Every substance is written correctly. Now we're going to balance it for numbers of atoms. 2, 2, and there we go. So that's it for this one, guys. We're going to practice this more and talk about it more in class. But that's all I have for you now, and have a good evening. Thanks for watching.